Alright, so we'll continue on the payoff phase of glycolysis. We stopped at the splitting phase, whereby with the help of aldolase, we were able to split fructose 1,6 bisphosphate into dihydroacetone phosphate and glyceride 3-phosphate. Okay, and I made mention that dihydroacetone phosphate will be converted back to what? Glyceride 3-phosphate. Is that not so? The enzyme that does this is basically an isomerase enzyme. So since both of them are triose, you can call it triose isomerase. Okay, mind you, this step is also reversible. Even this aldolase step is also reversible. So now whatever I do here will also occur here. Now this step we're about to talk about now is step 5. Let me just erase this first. Let me first put the details of the step first. Now this step now is that we are going to use a reducing, we're going to oxidize this step rather. So we'll take NAD, then form NADH. That's what happened at this step. So same thing will also occur here. We'll take NAD, then form NADH. Now mind you, it means that we remove hydrogen from glyceride 3-phosphate. Is that not so? And that is the word oxidation reaction. Now apart from this, there's also one thing we also do in this step. We added phosphate. We added what? Phosphate. And the phosphate is from what we call inorganic phosphate, Pi. So I will also include it here that we added phosphate, which is Pi. Are you there? Alright, so in step 5, apart from the oxidation reaction, you see, we also added what? Phosphate. Are you there? We also add what? Phosphate. Now what we get will be, by virtue of the oxidation reaction, the aldehyde will become glycerate. Like instead of being an aldehyde, it will become an acid. You know, you can convert aldehyde to the acidic form of it, which will now be spelled as let's say alkanoic acid. I get my point. So we convert the aldehyde to a carboxylic acid, and that is done by oxidation reaction. Are you there with me? So what are we? What are we form here must end with ATE. Same thing here, must end with what? ATE. So since I added the phosphate, I add the phosphate at carbon 1. So what I will form now is what we now call 1,3-bis phosphoglycerate. 1,3-bis-phosphoglycerate. Are you there? So let me add argo here. 1,3-bis phosphoglycerate. Same thing here. 1,3-bis. Sorry for that. 1,3-bis phosphoglycerate. Are you there? So that's what we form. Again, I will just explain it again. In this step here, which is step 5, we oxidize the molecule. At the same time, we added inorganic phosphate. Mind you, I said inorganic phosphate, not a phosphate coming from ATP, not from ATP. Please take note of. We do not use ATP here. We only added inorganic phosphate. Are you there with me? Now, what is the name of the enzyme that does this reaction? Since the reaction is a dehydrogenation reaction, we call it glyceraldehyde 3-phosphate dehydrogenase. So I will just put for short here, I will just spell dehydrogenase. So it's called glyceraldehyde 3-phosphate dehydrogenase enzyme. That's what we have in step 5. Now, mind you, step 5 will actually form NADH. very important, because this is an energy molecule that if it goes to the electron transport chain, it can form ATP for us, as we will see shortly. So just take note of the fact that step 5 forms NADPH. Very, very important. Very, very important. Very, very important. Now, the next step now is that we now remove phosphate. So we take ADP and form ATP. Same thing will occur here. We will take ADP and form what? ATP. So it means that we remove the phosphate at carbon 1. Are you there with me? So what is left now is just the phosphate at carbon 3. So we'll call it what? 3 phosphoglycerate. Same thing here, 3 phosphoglycerate. Now if you notice, at this step 6 here, at step 6 we form ATP directly. We form ATP here. Okay, so that's why we say this phase is the payoff phase. We form ATP in step 6. Now, this method of forming ATP without going to the electron transport chain is given a special name. It is called substrate level phosphorylation. Substrate level phosphorylation. Substrate level, okay, let me just spell it. Considering space, substrate level phosphorylation. Are you there with me? So it's called what? Substrate level phosphorylation. Commonly asked question. The formation of ATP without involving the electron transport chain is called substrate level phosphorylation. Now you need to know the enzyme at this step. It's one of the important enzymes you must know. The enzyme is called phosphoglycerate kinase. It's called what? Phosphoglycerate kinase. Phosphoglycerate kinase. I know things are becoming jam-packed, but please, I will appreciate you know this enzyme. It's very, very important. Phosphoglycerate kinase, because it's an enzyme involved in substrate level phosphorylation. Now, step 7 basically is that we are going to move the phosphate from carbon 3 to carbon 2. So instead of 3 phosphoglycerate, we have 2 phosphoglycerate. Here we also have 2 phosphoglycerate. The enzyme here, you don't need to remember it, it's reversible. It's a mutase enzyme. That's what you just need to know. It's a mutase enzyme. Enzyme that move one group from one position to another. So it's a mutase enzyme. So you can just call it 3 phosphoglycerate mutase. Call the substrate name and call the enzyme activity, which is mutase. Are you there? So that is the only thing that occurs in step 7. Very easy step. A mutase reaction. Now if we move further, the next thing to do now is that we are going to remove water from this molecule. So I will just indicate that water is removed. I will indicate that water is removed. And when you remove water, what you get is what we call phosphoenolpyruvate. Phosphoenolpyruvate. Okay, I know it's becoming complicated, but you just have to stay. It's very, very easy. Before you watch the video over and over again, you get the understanding. Very, very simple. Step 8, basically, we remove water. That's what happens in step 8, and we form phosphoenol pyruvate. Now, the name of the enzyme involved in step 8 is very, very important for you to know. It's called enolase. Enolase. Now, sharply contrast this with aldolase. They're not the same thing. Let me spell it here again. Enolase. Sharply contrast it with aldolase. Aldolase is for step 4, which does the splitting. Enolase removes water and we form phosphoenol pyruvate, abbreviated as PEP. Phosphoenol pyruvate. Are you there with me? Alright. Now there is a shunt somewhere. There's a shunt somewhere that will lead to what we call the Rappaport shunt, and that shunt basically will occur more in the red blood cells when they want to like offload oxygen. When they want to offload oxygen more better, so you will now see the formation of what we call 2,3 BPG. Formation of what we call what 2,3 BPG. Okay, that one is usually seen in the in the red blood cell. Formation of 2,3 BPG. It's a shunt on its own. Later on, when I will want to summarize everything in the video, I will lay more emphasis on that shunt. Basically, that shunt starts from this step here. Starts from this step here. Starts from that step 3 phosphoglycerate. We can from 3 phosphoglycerate form what we call 2,3 bis phosphoglycerate. And 2,3 bis phosphoglycerate helps the red blood cells to deliver oxygen effectively to tissues. Okay, so in setting of hypoxia, you will see high levels of 2,3 BPG. So now we'll move to step 9. Now, in step 9, what happened is that we are going to remove this phosphate and form pyruvate. So again, we see ADP forming ATP. Again, we see ADP forming ATP. Are you there with me? The name of the enzyme is called pyruvate kinase. Pyruvate kinase. Pyruvate what? Kinase. Very, very important enzyme. This step is also irreversible. This is the last irreversible step. Remember step 1, exokinase or glucokinase. Step 3, phosphofructokinase 1, and step 9, which is pyruvate kinase, are irreversible step. And another thing about this step 9 is that we notice that we also form ATP directly without going to the electron transport chain. So pyruvate kinase reaction is another example of what we call substrate level phosphorylation. I already said it before. Substrate level phosphorylation. Are you there with me? Substrate level phosphorylation. So in the glycolytic pathway, there are 2 steps involved. Here we see substrate level phosphorylation, and that is phosphoglycerate kinase step, which is step 6, and pyruvate kinase, which is step 9. Okay, so that is for that. So these things I'm saying are very important. Step 9. Are you there with me? Alright. Now, remember at the beginning I said the cell I choose to do my glycolysis is the red blood cell, and we know that the red blood cell does not do aerobic glycolysis. What this means is that the pyruvate will be converted to what? To lactate. Pyruvate will be converted to what? To lactate. But should it be that the red blood cell does glycolysis before, then pyruvate, instead of converting to lactate, will be converted to acetyl-CoA. That is, if oxygen is available. Like, sorry, if the red blood cell has the ability to carry out to carry out aerobic glycolysis. You know, the red blood cell does not do aerobic glycolysis. Reason because it lacks mitochondria. Okay, so if it had mitochondria before, then pyruvate would have been converted to acetyl-CoA for the case of aerobic glycolysis. But now, since it's the red blood cell, we are going to form lactate as our end product. And for the formation of lactate, we are going to take that NADH we form at step 5. Let me bring your mind back to it. This NADH we form at step 5. We'll pick it again and use it in this last step here. In this step. So we use the NADH. We have NADH. We're going to use it to reduce pyruvate to lactate, and we form NAD. And we form what? NAD. Okay? NADH. And we form what? NAD. Are you there with me? So that is it. So the NADH forms formed at step 5 is utilized to convert pyruvate to lactate for the case of anaerobic glycolysis. But if it was, sorry, let me spell the anaerobic very well. For anaerobic glycolysis. But if it was aerobic glycolysis before, then the NADH will be transported to the electron transport chain and be used to generate ATP for us, and we can get 2.5 ATP from one NADH. Are you there with me? Alright, so before I wrap up this video, I would just want to calculate the energetics of glycolysis. So energetics of glycolysis. How many ATP is formed from glycolysis? We already see that at step 1 we use 1 ATP, right? So minus 1 ATP. Is that also? In step 3 we use another weighting 1 ATP. Is that also? This part here, this side is for aerobic, is for anaerobic calculation. Anaerobic. Why this part is for aerobic? Okay, I will do aerobic on this side, and I will do anaerobic on this side. Are you there with me? So step 1 we utilize 1 ATP. Step 3 we utilize another 1 ATP. Now in step 5 we form 1 NADH, while in step 6 we form 1 plus 1 ATP. Since it's 2, since we were at this step 5, we already split. Then also we already split the, let me show you again so you get understanding. We already split now, so it is 2 NADH we formed. So let me quickly put it there. So we form 2 NADH. Is that not so? Is that not so? Meaning at step 6 we form what? 2 ATP. Then again at step 9, which is another substrate level phosphorylation step, we form another 2 ATP. Now since this case now is anaerobic glycolysis, we are not going to use this one to get any energy. We're not going to use it to get any energy, since we are going to use it to convert pyruvate to lactate. So our calculation will now be minus 1 equals to minus 2, and that minus 2 plus 2 ATP, it means that we use this one to cancel these 2 minus here. Are you there with me? So I'm left with just this plus 2. So that's why I said in anaerobic glycolysis we have how many ATP form? 2 ATP that is formed in anaerobic glycolysis. While for aerobic, again the calculation goes the same. minus 1 ATP for step 1, minus 1 ATP again for step 3, then plus 2N ADH for step 5, plus 2 ATP for step 6, plus 2 ATP for step 9. Now, this 2 ATP, we cancel these minuses here. Are you there with me? So I'm left with this 2 ATP plus this 2 NADH. And 1 NADH is equivalent to 2.5 ATP. So if I do 2 times 2.5, I'm going to have what? 5 ATP. So when we add this 5 ATP plus this 2 ATP, we get what? 7 ATP. So that's why I said at the beginning that aerobic glycolysis produces 7 ATP, while anaerobic glycolysis produces 2 ATP. Okay, so that is the calculation behind it. In the next video, we will continue with, I'm going to highlight some key steps from glycolysis, and some key substrates in glycolysis, some key shunts in glycolysis, and we will also talk about the regulation of glycolysis. Okay, just to give you the irreversible step. Remember, in glycolysis there are 3 irreversible steps. Step 1, 3, and 9. Yes, step 1, of course we don't really cram the step though, but the main thing is the enzyme. Step 1, exokinase or glucokinase. Step 3, PFK1. And step 9, pyruvate kinase. Okay, so in the next video we will continue from where we stopped today. Thank you very much.